where today we attempt to, by various means and measures, repair the brake system on the old Dodge pickup. Now, this thing originally had an ABS module in the back, which it no longer has. This thing originally had a proportioning valve and distribution block on the frame rail up front, and it no longer has that either. So we're going to kind of go into what it takes to make this work first and foremost. Now, it's a front disc truck and rear drums. When you have rear drums, you require a residual pressure valve of about 10 psi. So I got on the interwebs and bought a 10 psi residual pressure valve, and I bought a Willwood proportioning valve because it's actually a little bit easier to lock up a set of rear drums than it is to stop suddenly with the discs. So we're going to have to take some bias off of the rears, which are normally about 40% of your total stopping force, in some cases 30%. But when your rears lock up first, which these have had a tendency to do since I bought the vehicle, especially in wet weather, and the rears lock up and the fronts aren't, the rear tends to go just kind of wherever it wants to. We're using 3/16 line, but I did have to go back and reuse some of the factory fittings, which is fine. I just chucked up a drill bit that was a little bit smaller than the factory 3/16 size to allow myself maybe a 16th total here. Ground the edge of the line down where I could get a drill bit in it, and using the drill press drilled it out. Once that was on and a flare had been added to it, we just went through, and I have already bolted the proportioning valve down and just kind of make some cuts and move some stuff around. And I did use metric fasteners to fasten it down, but it's because I liked how they fit and I had the appropriate length, and they were black oxidized instead of zinc coated, and I think that'll look better under the hood. So 5 minutes into this particular time-lapse video, we're bending some line here. I'll go ahead and we'll kind of chuck it back up, and you'll see a lot of I chuck it up and then I make a mark, or I move it around here and do that. And a lot of this is done by eyeball, but as much as you can mark or measure as you get used to your setup is better, really. Now, there's so many angles, and you'll never get it all the way mocked up when you're dealing with long sticks of line. So you got to keep in mind that some of this is going to be a hand adjustment, which is yet another reason I use the nickel copper line. I really like this stuff. It's incapable of rusting. It flares very easy. And if I need to adjust something with my hands, it's so easy to do. I don't have to worry about, I can squeeze hard enough to pop a finger out of joint or a knuckle out, and it'll hurt for days. And with doing this, I don't put myself at that particular risk. I've been really happy with it, and it holds pressure just fine, especially on a vehicle like this. But again, a lot of hand adjustments. Once everything's pretty dang close, you got to tweak her just a little bit when she goes back in. So those big factory style fittings, you get them in, you go ahead and, I had already put the adapters on the proportioning valve, throw some fluid in it, and try and get stuff moving around a little bit, and fluid just starting to kind of go through the system while we're in there. Now, I didn't take any video of the actual bleeding process. First off, a lot of people already know how to bleed brakes, and really, if we're going to go through the nuances of different ways to bleed brakes, it should be its own video. It shouldn't be something that I hide within this particular brake line bending deal. I would like to also take this opportunity to note that residual pressure valve I bought from Speedway, it's a polished stainless unit, a pretty nice little piece. It did not come with the adapters to run from the 1/8 inch NPT to the 3/8 24 fittings, which normally go over the 3/16 standard style line. And doing that kind of put me off a little bit. I knew I needed a couple fittings, but I ended up calling around and having to find a parts store that had the vast majority of this in stock, and then the parts store next to us in an adjacent town had the rest of it. Had to go on a parts run for that, and I like to know that kind of thing going in, and would have loved to have known that it was going to require a special adapter beforehand, as I had already ordered pretty much everything. I was hoping to be able to just throw it together, but custom work is custom work, and very rarely on doing something custom can you just throw it together. Take note too, as I start the vehicle here, that the numerous amount of zip ties is waving in the wind of the fan here. There will come a time when I go back and trim off zip ties. There's our residual pressure valve. It's just not right now. It's more important to me to get the vehicle running correctly and tuned in, and then go back and finish. We are taking the time to 3D print, design and 3D print a holder for this residual pressure valve. I'm sure there's someone out there that makes some sort of a holder for a residual pressure valve. I didn't see them anywhere, and honestly, with its construction, it would be just fine to kind of set it on a frame rail with maybe a zip tie around it, but I have mine kind of out in the open, as it's another piece that could potentially fail or leak, and I want to keep that out where I can see it best I can. I originally mocked this up to be made out of a carbon fiber PA6 nylon, but for whatever reason it was jamming in the printer, and I just have an old model printer, and it was not very happy with that. It doesn't like to run at those temperatures anyways, so we went ahead and I ended up switching back over to the Overture TPU, which I use quite a bit. But at this point I was still thinking nylon. Doesn't really matter. That's where we were at. All the dimensions here were made by using the extruder tool for the most part from the sketch. Didn't really factor anything crazy in. I didn't start a sketch from another plane. It's a 3D printed piece, but it's pretty much just a screwed with two-dimensional drawing. It's really nothing fancy at all, and that's okay. I left some spaces on the edges to put a couple zip ties around, one on each end, and capped each end where, as long as it's kind of in there and it's made where it's a little bit smaller so it'll kind of almost snap onto it, it should be just fine. The zip ties are just kind of insurance at that point. And then the bracket on the back doesn't have any holes drilled in it at this point, because I'm not sure where everything's going to end up, and it seemed like being able to use a self-tapper in this application would just be the best thing I could do. I had some issues with the extrusion. Did go through and look up. You'll see here where I pulled specs and moved everything. Not extrusion, exportation of the file, but went ahead and got that done. Have it loaded into the slicer. Then we'll come back over here and try and get the rest of our pieces flared that need to be flared while this thing is printing. So this is a piece I had actually replaced all of the line back to the rear axle flex hose sometime late last year, when the truck was still running pretty dang good of its own accord and had not decided to eat 2 ECMs, one of which tried to catch fire. So at that point, I had already replaced it with nickel copper and had reused one of the fittings going into the proportioning valve / distribution block here. I took this opportunity to delete that particular fitting and run back to a 3/8 24 threaded fitting that comes from the 3/16 line in its natural habitat. Again, not a huge deal, but we did that. We do a couple little moves and folds and run that line back up. It actually ended up running all the way up underneath kind of the steering shaft on the vehicle, which made a handy connection when going from, I think I made like a 38 or 40 degree turn out of the residual pressure valve going into the rear line. And that turned out pretty slick. I was pretty happy with how that turned out. Again, I've mentioned it before, this type of flare tool is by far not my favorite. Many moons ago, while working at a Chevy dealership, I had the opportunity to use one of those hand-pumped hydraulic flare tools. It was a J tool. I think it was made by Kent Moore. All the dealership tools pretty much are in the GM world. And I was so happy with it, and they were so expensive at the time, I never bothered to buy one for myself. At one point in time, I think I looked into or maybe even purchased one that was made by Harbor Freight, but I never could find it. And now I'm back to, I believe this is an OEM Tools version, similar to the ones sold on Amazon, eBay, and AutoZone maybe. It's a decent tool, but it's not the hydraulic tool. The application of pressure there was so smooth. I liked it a lot. And at one point in time, I had one of the inline flare tools that came from Matco, and it was a nice tool as well. It was a good square because it held everything square of its own accord. I always had a pretty good flare with it, and it allowed me to run flares on the vehicle inside frame rails and stuff. Really neat tool. So go ahead and got all this down, everything. Went ahead and turned the flow up a little bit just for bleeding purposes, and while it was bleeding, we came back here and restarted the printer. Again, this is TPU printing, around 212 degrees-ish, and being filmed, I think this is 50 times speed. This was a legitimate 2-hour and 20-ish minute print, as shown here. I'm sure some people will like just the print, and that's fine. If you feel the need to copy that holder for the residual pressure valve, go ahead. I'd share it with you, but I'm probably not going to get into that at this time, just because I'm between the YouTube channel and the shop, we're a little too busy for that. However, this was a good opportunity to do a time lapse on this and let the little Creality printer do its thing. It is keeping around a 60-degree plate temperature, which is that glass plate I have there. It comes with a little plastic plate, but its reusability is not as good, and my head adjustment on it is not always perfect. And this is just a little bit more forgiving in some ways, and I need all the help I can get. It's also, its adhesion for nylon and materials of that nature is quite a bit better, and it allows me to use just a regular glue stick, Snow Elmer's glue stick, on that surface, and then I can, once it's cooled off, I've actually been known to, when the wife's not home, take it inside, soak it in the sink, and it'll kind of rehydrate all of the nasty dried out glue stick on it. At that point, I just scraped it off and washed it, and everything was fine. You don't want to put that down your sink, by the way. TPU, which was the flexible material that I've printed a lot of things out of, is not as chemical resistant as a lot of nylons and stuff are. However, this was a good application for it because it is flexible. And when I put the zip ties around it, I'll be able to kind of squash it down onto there a little bit. I will mention that I did not go back and re-slice this for TPU. I had originally sliced it for nylon, which means that I put about a 4% oversize on it for scale, because nylon has a tendency to shrink. Now, as nylon is hygroscopic, it will pull moisture out of the air, and you can actually throw it into a bucket of water to help it rehydrate and do fairly well with it. But at this point, I just let it roll, because an extra 4% of diameter at that rate is not very much at all. And I just figured it would be just fine, and as it turns out, it was. I had planned on doing a video showing you how I pulled all the material off of it and kind of cleaned it up, but I had a customer call right about then and kind of unconsciously pulled all the crap off of it. So there she is. It's the Overture TPU that we used for it. And take it outside and stick it on the truck. Once again, please ignore all of the random wiring I'm still in the process of pulling the harness on this truck. It's actually happening whilst I edit this video, but at that time, this was just to get it running and moving under its own juice. Having the little pink wire there that runs to the HEI style distributor really has just worked. I'm going to go back and reuse the wire that came off the ASD relay, but at that time had not done it yet. These are just regular old zip ties. I realize a black zip tie would have been the added touch I needed. I am going to buy some pretty nice zip ties and probably a zip tie gun fairly soon. But at this time, again, we're just shooting for functionality. Functionality is a big deal when it comes to this kind of thing because first off and foremost, the truck has to be usable, and then, kind of a rolling sort of almost advertisement. Strictly second, maybe third. Usable, sort of safe. See, safety third would make pretty fourth, right? Depends on what shows you go to. Anyways, that went on like that. I went ahead and I had brought some self-tappers out. I've got these stainless self-tappers I've been buying. I don't remember the brand of them, but it's a blue or greenish label on a package. It's clear. I bought this Diablo extended reach bit from the local hardware store, and it's been pretty good. They've got a speed loader I've been using on it as well. It works very well. I'll go ahead and stick a couple of these self-tappers in here at this time. There she goes. So you can see that the TPU is pretty easy to drill through. It's not as hard as a lot of the plastics, and because of that, in most of my applications, I've had a lower failure rate. Like most things, if the metal that I'm working with, or whatever, plastic in this case, is too rigid, it will actually find a way to crack and break. And that's pretty much it, guys. Everything else is just bleeding brakes, which I'm assuming you already know how to do. If not, we'll make a video on it. Just let me know. Thank you for watching. Please use our affiliate links, and have a great day.